Okay guys, this is section 10.1 on inverses of simple quadratic and cubic functions. What we're going to do in this video is I'm going to finish off the examples that I started in class but didn't finish. So example number 1 and number 2 down here at the bottom. So as you can see, these are the notes that you guys received on Monday. After I finish those two examples, I'll ask you guys to practice a few on your side as well. And then we're going to move on to Tuesday's notes, which you should already have and you have glued onto your notebook. Okay, so here we go. Let's get started. Okay, so here the instructions are telling us to restrict the domain of each quadratic function and find its inverse, then confirm the inverse relationship using composition, then graph the function and its inverse. So we're doing three different things here. We're restricting the domain of each quadratic function and then finding its inverse, right? Then we're also going to be confirming the inverse relationship using composition, and finally what we're going to do at the very end is to graph the function and its inverse. So there's three different things there that we need to take care of. So let's get started on restricting the domain and finding the inverse. So we're going to start with number 1. Alright, let's start with number 1. It says f of x equals 0.5x squared. Restrict the domain, find the inverse. I want to explain in a little bit more detail how to restrict the domain, which is something that I don't think I did in class because I was going kind of fast at the end of the period. So restricting the domain. Here, when you're restricting the domain, it's very important to know what h and k are for this particular problem. Because if you recall, h and k for quadratics, which is what we have here, is the vertex, right? So that is the central point of your graph. Recall that HK are values that come from our standard form right here, and they always represent the vertex of my graph. So if I know what those points are, it's going to help me figure out which side of the graph I'm going to be getting rid of. Usually the left side. We don't want the negatives, right? We want the positives most of the time. Although sometimes it's going to be helpful to use the left side. So you need to find h and k so you can know what the vertex is. And once you know where the vertex is, you have to know, okay, I want the values to the right of those, okay, starting with that x value and above. We don't want the negative ones, okay? So here, if you guys look at this, it's actually very simple. This is A, right? You recall that's A. It doesn't look like there's an H or a K, right? Which means that my vertex in this case is 0, 0. Okay, that is your central point of your graph. Just real quick, look, let me draw this. You don't have to copy this, but just let me draw this. That's what this looks like, right? It's a parabola, and this is the vertex, 0, 0. That's all I know about the graph. What also we know is that we need to restrict the domain. We only want the positive side, so we don't want this part. If this point is 0, 0, that means that we only want the x values that are greater than or equal to whatever this x value happens to be. So really all you're doing is finding h, that's the only important part of your vertex right now, finding h. If h is 0, then you only want the positive ones, any numbers that are greater than or equal to 0. If h is something else, whatever h happens to be, your domain will always be restricted by whatever h happens to be. Go ahead and write that down and highlight it somewhere. I suggest you put it somewhere in the box or near the box or outside the box, but somewhere where you can easily see it and find it. That's going to be your domain right now. Okay, that's going to be your domain for most situations. Domain, that right there. Okay, write it somewhere where you can easily find it, not in the middle of your box, but somewhere else where you can easily find it, like up here or maybe over here on your box. Okay, once you have that down, finding the domain is going to be pretty simple. Okay, here we go. Let's finish it. So my domain, as I said, is all the values of x such that x is greater than or equal to h. In this case, it's 0. Your h value is what's important for your restriction of your domain. What you're saying here, once again, is that we only care about the right side of the parabola. We only care about that side. We don't care about the entire thing. Okay, just from the vertex and then up like that. All right, let's find the inverse now. Here we go. The first thing we're going to do is change f of x to y. So y equals 0.5x squared. The next step you're going to take is to isolate the x squared. You want the x squared to be by itself. Do not take the square root right now. right? First get rid of the 0.5. Then, once you're left with just x squared, then you can get rid of it. So we're going to take the square, divide by 0.5 to get rid of it. This is something that when I did it in class, some people got confused. When you divide 1, this is 1, divided by 0.5, think about this. What you're really doing is 1 divided by 1/2, right? 0.5 is 1/2. 1 divided by 1/2. So what you're really doing is 1 divided by 1/2. You can turn this into a fraction so you can do the division. If you remember your rules of division of fractions, this is 1 over 1 times, what you do is you take the reciprocal of the second fraction, 2 over 1. So that gives you 2. Yes, I did it in class kind of fast. 1 divided by 0.5 is actually just 2. You could also just punch that into the calculator. It's going to give you 2. So what I get here is 2y equals x squared. Now that all I have is x squared right here, now I can get rid of the square by taking the square root of both sides. So you're going to take the square root of both sides like this. Square root, square root. What that does is that the square right here and the square root are going to cancel each other out. It's the inverses of each other. It's like multiplying and then dividing, right? Those cancel each other out. Adding and then subtracting. Squaring and then taking the square root, those cancel each other out. Like that. Leaving you with just x. On the right side, on the left side, you have radical 2y. Final two steps, flip the x with the y. So this is going to be radical 2x instead of radical 2y is equal to y. I like it on the left side, although you could have left it on the right side. Finally, change the y to f inverse. So f inverse of x is equal to radical 2x. And that's your inverse. So we're not done there, right? The next step is to confirm that it's the inverse using composition. Right? That's what it says right here. Confirm the inverse relationship using composition. So that's what we're going to do next. I want to do a composition to confirm that this actually is the inverse. So here we go. Composition means plug one function into the other one. So what we're going to do is we're going to either plug this one into this one or this one into this one. Either way, your solution should be x. It's all you should be left with. Okay. What I'm going to do is plug this one in here. Okay, so this is what I have. Radical 2x. But instead of x, what I'm going to plug in, this is radical 2x, this one. What I'm going to plug in here instead of x is all of this, 0.5 x squared. And simplify it. 2 times 0.5 is 1, right? 2 times 1/2 is 1. So what you have actually is radical 1x squared, which is just radical x squared. And like we said before, the radical and the square cancel each other out, leaving you with just x. And that confirms that this is a inverse because the composition worked out and gave me x only. Right, the next step we're going to take is to graph both of them, the inverse and the original. So what we're going to do is we're going to graph the original, 0.5 x squared, and then I'm going to show you guys how easy it is to graph the inverse after you graph the original by just flipping the points, right? Which is what the inverse is. You just switch the x and the y values. So here we go. Let's graph the original. What I'm going to do to graph it real quick, this is going to be simple, is to make a small table of values. Only 2 or 3 points is all you need. You don't need that many, okay? Choose your x values correctly. Remember, we said the domain is x is greater than or equal to 0. So you should not choose any negatives, right? Anything that is bigger than 0, including 0. So we're going to do 0, 1, and also 2. Why not? 3 points. That should be good enough. What are you going to do with those 3 numbers? You're going to plug them in here to see what you get. Okay? You can pretty much use mental math here because these are not very complicated. So 0 squared is 0 times 0.5 is still 0. 1 squared is 1 times 0.5 is 0.5. 2 squared is 4. 4 times 0.5, which is 4 times 1/2, is 2. There you go. That's your original. That's f of x. Let's label it correctly. That is the table we're going to graph to make f of x. What's our table for f inverse then? Well, it's the exact same numbers, just reversed, right? That's what the inverse is. So 0, 0 is still 0, 0. 1, 0.5 is 0.51. And 2, 2 is still 2, 2. There we go. We're ready to graph it. What I'm going to do, since everything here is positive, is I'm going to make a coordinate plane where everything is positive. Here's my y-axis. Here's my x-axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That should be good enough. We don't need that much space. Let's graph the original first, right? The pre-image. 0, 0. I'm going to graph it in red. 0, 0. 1, 0.5 is right about here. And 2, 2. There you go. If you connect these dots, it looks like that. And only like that. We are not going to draw the left side. Remember, we restricted the domain. Alright, for this one, I'm going to make this one in blue, so it matches. 0, 0. Again, right there at the origin. 0.51 is right here. Right? The x value is 0.5. The y value is 1. And 2, 2. So this one actually goes this way and then turns like that. And there's your original and your inverse. Alright, let's move on to number 2. Now that you saw me do that one, I'm going to move a little bit faster on this one while still explaining the steps. Okay. First of all, to restrict the domain, we need to find the vertex, which is h and k. You should be able to, at this point, figure out what h and k are easily. For example, this is k, right? H would be in here, inside parentheses with the x, but since there's nothing there, that means that h is 0. hk, in this case, the vertex, is 0, negative 7. Right? If you're confused about that, remember B, H, A, and K. Here's K. H would be in here, but there's nothing there, so it's 0. Remember what I said about the domain? The domain is restricted by H. Wherever your vertex is, you only want the positive side most of the time. Okay, so we're going to restrict our domain to say that the domain is all values of x such that x is greater than or equal to 0. So once again, just like in the last one, we only care about the positives. Alright, let's find the inverse. Once again, f of x means y equals x squared minus 7. We're going to add 7 to both sides. So it's y plus 7 equals x squared. Now we're going to take the square root of both sides, like that. The x squared, the square and the radical are going to cancel each other out, leaving you with just x. And on this side, nothing cancels. You have y plus 7 inside the radical like that. We're going to switch the x with the y and also flip them around so that the y is on the left side. Okay, so this one becomes y, but I'm going to write on the left. This one becomes x, but I'm going to write all of this on the right. That's what I'm doing. Y is equal to radical x plus 7. Finally, change y to f inverse. F inverse of x equals radical x plus 7. There's your inverse. We're going to check it by doing a composition, right? Composition means you're going to plug this one in here for x, or this whole thing in here for x. Either way that you go, your result should be x, right? That's all you should have left. So here we go. We're going to start with the original. So f of f inverse. This is a composition. Remember what this means? It means I'm plugging in f inverse into f, right? We went over that a bunch of times. You're plugging in f inverse into f. So f of f inverse is x squared minus 7. Instead of x, I'm going to plug in radical x plus 7. And what's going to happen is that the radical and the square here are going to cancel each other out, right? They're inverses of each other. They're inverse operations. Leaving me with just x plus 7 minus 7. plus 7 minus 7 will also cancel, leaving you with just x, and there you go. We have confirmed the inverse, that is the actual inverse, because the composition worked. Alright, next what we're going to do is we're going to graph them both. And once again, all you got to do is make a small table for your original, and then just flip the values around for your inverse. You could also make a table for your inverse and then flip them around for the original, but these are usually easier to work with. Okay, so let's make a table for that one. I'm going to make it in red so that I can graph it in red. This is for the original function, the pre-image. Once again, don't forget to check what you restricted your domain to. Since we chose only values that are greater than or equal to 0, I'm only going to choose 0, 1, and 2 here again. Only positive values and 0. Alright, let's do mental math. Plug in 0 right here. 0 squared is 0, minus 7 is negative 7. Do 1. 1 squared is 1, minus 7 is negative 6. And 2. 2 squared is 4, minus 7 is negative 3. There you go. For the inverse, we're going to do it in blue. And then we'll graph them both. This is the inverse. All you got to do is just flip the values, right? Negative 7, 0. Negative 6, 1. Negative 3, 2. Alright, let's graph those. Looks like I have a y-axis right here. I'm going to use this line as my y-axis. And an x-axis here. No, actually, I'm just going to move a little farther out. You guys can squeeze it in down here below your notes in your notebook, okay? So here's my x-axis, and here's my y-axis. Oh, it looks like I need everything. I need positives and negatives for x's and y's. Okay, so I'm actually going to need both of those like that. Alright, 1, 2, 3, 4, 5. That should be good enough. Actually, no, I need to go all the way to negative 7. 6, 7. And then on the y-axis, 1, 2, 3, 4, 5, 6, 7. On the y-axis below, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. 1, 2, 3, 4, 5, 6, 7. That should be good enough. Alright, let's graph the first one, the original in red. 0, negative 7 is down here. 1, negative 6 is down here also. And 2, negative 3 is down here also. So it looks like this. Half a parabola once again. You don't need the other side. For the inverse, negative 7, 0 is way out here. Negative 6, 1 is right here. And negative 3, 2 is right there. And so it starts here and it's going towards those like that. There's your original and your inverse. Alright, one quick point that I need to make. If you look at the original, this red one here, the domain, the x values are all greater than 0, right? We only restricted it so that they're all greater than 0, all the positive x values. The range, if you think about it, the range starts with negative 7 and it's everything above negative 7. Remember, the range are the y values. So negative 7 is the smallest y value and it goes up. So the range is all the values that are greater than or equal to negative 7. If you look at the inverse, they have flipped. The domain of the inverse, the x values, start at negative 7 and go up to the right, right? So all the x values that are greater than or equal to negative 7. And the range of this one is from 0 up. All the y values that are greater than or equal to 0. So just like we did before, the domain and range of the original flip with the domain and range of the inverse. Let me write that in up here so you guys can see it. Okay. For the original, we'll call the original f of x because that's what it's called. The domain is all the values of x such that x is greater or equal to 0. That's what we wrote out here at the beginning when we started graphing it, right? It's also visible in the graph. All the x values are positive or 0. The range, although they didn't ask me for the range, I want you guys to be familiar with it. The range is the y values, all the y values such that if you look at it, the y values start here at -7 and then go up. So y is greater than or equal to -7. You see that? Starting at -7 and then up. For the inverse, I'm going to write it here, f inverse, the domain is all the x values. Look at the inverse right here. All the x values starting at -7, x values, not y values, starting at -7 and up, right? All the x values that are greater than or equal to -7. Let me undo that because I just messed up. Fix it. -7. And the range, all the y values, look at it, it's all the y values above 0. All the y values that are greater than or equal to 0. And if you compare them to each other, you can see again that the domain and the range have flipped roles. The domain and the range here have also flipped roles, right? Y is greater than or equal to -7, that's the range of the original. But in the inverse, the domain is x is greater than or equal to -7. See how that still works out, just like we learned before. Right, and that's your finished work. Okay, so what I want you guys to do is go to your side and try number 3 and number 4. Take, let's say, 4 minutes for each one. Take 8 minutes right now. So you guys can set yourself a timer, or whoever is there can set a timer for you guys. Take 8 minutes, 4 minutes for each one, and try to complete both 3 and number 4. Okay? Once you guys have tried it, once you've taken 8 minutes to try them, go ahead and unpause the video so that you can see the correct solutions, which I'm going to do also right here. Okay, so I'm going to show you the correct solutions, but go ahead and pause it right now so you guys can try it on your own for about 8 minutes. Okay, go ahead and pause now. Alright, so here's the correct answer. I noticed after looking at both 3 and 4 that I wrote the exact same function, so that's an issue. So don't worry about 4, I guess. It's the exact same thing. Let's just look at number 3 then. Number 3, the domain is restricted to x is greater than 0, greater than or equal to 0, once again, because that's the h value, right? We only want the positives at that case. I worked the inverse. Here's my work right here, and this is what I came up with for the inverse. I divided by 3 first, and then I took the square root of both sides. So I got that. Then I did the composition to check. What I did here, notice what it looks like right here. Remember we talked about this. This means that you're plugging in f into the inverse, into f inverse. So here's my original f, and then right here in place of x, I plugged in the the original, which was 3x squared. The 3 and the 3 cancel, leaving me with radical x squared. The square and the radical cancel, leaving me with just x. So that confirms the relationship. Here's my table for f of x. F of x is up here, 3x squared. Notice that I only use 0, 1, and 2 because my domain, again, is restricted. 0, 1, 2, 3, and so on. This one came out too big, but it's okay. I still did the inverse by just flipping the values. And here is f. 212 is somewhere way up there. I didn't actually draw it. And here's the inverse, f inverse. Okay. And that completes that section. The last thing I want to mention is the domain is x is greater than or equal to 0 for the original. The range, if you look at it, starts also at 0 and goes up, right? The range is determined by the k value. And the domain is determined by the h value, right? So the range is y is greater than or equal to 0 also, which means that the domain and range for the inverse are exactly the same thing, right? The domain is greater than 0. The range is also greater than 0 because it's going up. There you go. All right, what we're going to do now is move on to 10.2. So make sure you have your notebook on that page, and let's move on to that one. All right, so here's 10.1, day 2, right? Second part of the same function. As always, let's start by highlighting the essential question. What functions are the inverses of cubic functions, and how can you find them? The actual essential question is incorrect here, but that's okay. We'll leave it like that. I'll explain what's wrong with it once we're done with the examples. Okay, so the main idea here is that we're continuing what we worked on yesterday and earlier today on finding the inverse of a quadratic. But today, on this section, we are working on models, right? Real life situation, real world situations that we might encounter where we have some quadratic functions and we have to find the inverse, which is going to be a radical function. Okay, so The only thing that I want you guys to highlight here is something that you highlighted before when we were talking about real-world applications. When working with real-world applications, do not reverse the x and the y, or the t and the d, or the e and the v. Do not reverse your variables with each other, because in real-world situations that would not make sense. Okay. Also, sometimes, actually many times, in real-world situations, it is more useful, instead of writing this or f inverse, it is more useful to, if my variables are, for example, x and y, then I can just reverse them and write it like this. Instead of x of y, I write y of x. Instead of d of t, I write t of d, and so on. Okay, makes it a little easier to understand which is the variable that we're plugging in this case the t, and which is the variable that we're getting as an output, in this case d, right? So let's work on number 5 real quick. It says find the inverse of each of the quadratic functions, use the inverse to solve the application. So here we go, number 5. It says the function d of t equals 16t squared gives the distance d, so d is distance, in feet that a dropped object falls in t seconds. Write the inverse function to find the time t in seconds it takes for the object to fall a distance of d feet. So t in this case represents time, seconds. D represents distance in feet. In however many seconds you let this object fall, it will fall whatever distance you get here. Okay, we're going to find the inverse so that we can plug in d and get t out of it. Right? So first we're going to restrict domain. In this one, you're going to use a little bit of common sense and a little bit of the information that they have given you. Time does not move backwards. So the domain that we care about, if we start counting right now, is 0, meaning 0 seconds have passed, and above. So my domain is going to be, let me erase that, that was a mistake. All values of t, t for time, right? That's the domain, the t value, not the d value, that would be the range. All values of t such that t is greater than or equal to 0. There you go. That's my domain. So we only care about 0, positive time. 0 and positive for time. Let's find the domain. Here we go. It says d of t is equal to 16, equal to, not colon there, 16t squared. What I'm going to do to make my job easier is change this d of t to just d, equals 16t squared. The same thing, we're saying d is as a function of t, but we don't want to be messing with function form, so we're just going to change it to d. It's the same thing as when you change f of x to y, right? We're going to solve for t by first dividing by 16. So t squared, I'm flipping in the t squared to the left side, equals d over 16. Take the square root of both sides to cancel the square. So you get t equals, now in this side over here, look at what I'm going to do. I notice that 16 is a perfect square, right? D is not. So what the way I'm going to write it is like this. Radical d over 4. Notice that the radical is only for d, not for the 4, right? Because I took the square root of 16, gave me 4. I don't need to put it over a radical again because I already took the square root. There you go. We're going to write it in function form. The way that it's written here, I want to write it here. So the way that I'm going to finish is to write t of d equals radical d over 4. Done. Notice, once again, that I did not flip the t with d, right? We didn't flip it. We didn't reverse them with each other, right? For real-world applications, this is good enough. Okay. It says write the inverse function to find the time in seconds it takes for the object to follow the distance of d feet. You're done. That is it. Radical d over 4. Now, what this allows us to do is, if I wanted to, I could plug in a distance and find out how long it takes for the object to fall that distance. Whereas this one allowed us to plug in a time and figure out how far this object would fall in that given time. Okay, so look, this one you can plug in time to get distance. This one you can plug in a distance to figure out the time. That's the difference between the two. Okay, before we move on to number 6, I want you guys to go to your side, okay, and try, let me see, try number 7 and 8 there, which, by the way, the numbering is incorrect. It should be 1 and 2, but it came out like that. Let's keep it. Try number 7 and number 8. These are just like the ones we did yesterday in class and we did earlier today in 10.1, okay? So try those two first before we move on to these over here. I want to see if you guys still remember how to restrict the domain and find the inverse. Don't forget, restrict the domain means find h, and you want anything that is bigger than or equal to h. Same thing here, find h, anything that is bigger than or equal to h. Find the domain, restrict the domain, find the inverse, do a composition, and then see if you have enough space. You have very limited space here, but try to see if you could do a quick graph of the function and its inverse. Go for it. Take, once again, 4 minutes for each one, 4 for this one, 4 for this one. Take 8 minutes to work on that. Pause the video and then come back to see the correct answer. Okay, so here's the correct solution for number 7. You can see here that the first thing I did was find the domain. Once again, it's provided by h. H is 0 once again, so x is greater than or equal to 0. Here's my work for the inverse. I changed f of x to y. I multiplied both sides times 7. I took the square root of both sides. I ended up with this, which I turned into f inverse equals radical 7x. Once I got that, I checked by composition. Here's my work. I plugged in the original into the inverse. This is what this is showing, right? The original into the inverse. So the original was radical 7x. Instead of x, I plugged in x squared over 7. The 7 and the 7 cancel, leaving me with radical x squared. The square and the radical cancel, leaving me with x. Then here's my work for the graphs. This is the table for this one. Once again, like I said, I restricted my domain to greater than or equal to 0, so I chose numbers that are greater than or equal to 0, 0, 1, 2. Plug those numbers in here, and I got 0, 1 over 7, and 4 over 7. You may turn those into decimal if you want. I left them as fractions, that's okay, because I'm going to estimate when I graph anyway. That's the original. The inverse are just the flipped numbers, right? 0, 0, 1 over 7, 1, 4 over 7, 2. So here's my original. 0, 0, whoops, let's go back. 0, 0 is the first point right here in the origin. Let me scroll this up right here. 1, 1 over 7 is right here, and 2, 4 over 7, approximately right there. So I make this curve that is kind of heading up. It is still half of a parabola, right? It still makes that U shape. It's just really extended, really stretched out. For the inverse, here's my points, just reversed. So 1 over 7, 1 is right here, and 4 over 7, 2 is right there. So it makes this shape, right, like a sideways parabola going to the right. And there you go. Okay, for number 8, same idea. Restrictive domain. Again, h is 0, so greater than or equal to 0. Here's the work for my inverse. I got f inverse is equal to radical x minus 2 because I subtracted the 2 and then took the square root of both sides. Here's my work for the check. In this case, I decided to plug in the inverse into the original. So here's my original, x squared plus 2. Here's x squared plus 2. In place of x, I plugged in radical x minus 2, the inverse. The square and the radical cancel. The negative 2 and the positive 2 cancel, leaving me with just x. So that checks out. Here's the table I made for the original. Again, my domain is greater than or equal to 0, so I chose 0, 1, and 2. Plugged them in. Got 2, 3, and 6. 0 squared plus 2 is 2. 1 squared plus 2 is 3. 2 squared plus 2 is 6. Reverse them for the inverse, and I got that one right there. In this one, it's easy. It's important to point out that if you look at this one, the domain is x is greater than or equal to 0, right? Like we said. The x values start at 0 and go that way. The y values start at 2 and go up. So the range is y is greater than or equal to 2. And notice that in the inverse is the exact opposite. The domain starts at 2 and goes to the right. X is greater than or equal to 2. The range starts at 0 and goes up. Notice how the domain and range once again are reversed with each other because they're inverses. Alright, let's go back to my side now. Okay, let's move on to number 6. It says the function E of V equals 4V squared gives the kinetic energy E. So E stands for kinetic energy. Alright, so we know that. I'm going to highlight that part. E stands for kinetic energy. In joules of an 8 kilogram object that is traveling at a velocity of V meters per second. So V stands for velocity. E is kinetic energy, V stands for velocity. So if I know the velocity, basically is what they're telling me, I know the kinetic energy. This is specifically for an 8 kilogram object. They don't switch that throughout the problem, you can see. So this is just for an 8 kilogram object. Alright, let's continue reading. Write and graph the inverse function V of E to find the velocity V in meters per second required for an 8 kilogram object to have a kinetic energy of E joules. Then estimate the velocity required for an 8 kilogram object to have a kinetic energy of 60 joules. Alright, so that's a lot of information. What I take away from here, what I'm going to highlight here, is what they want us to do. Write and graph the inverse function. That's the important part right now. So this is the original function. You know what, let me highlight that in a different color, just so you guys can see. That's the original function, and they want us to write and graph. Again, let's highlight this in a different color so you guys can see it better. Write and graph the inverse function V of E. Okay, so knowing that, let's get started. It says to restrict the domain once again. So once again, I'm going to restrict domain using my common sense. The domain, look at the original. The domain is given by V, right? By the independent variable. The domain is all values of V such that V, think about this, if we're talking about kinetic energy of an object that is moving, kinetic energy is an object that is traveling, the velocity must be greater than or equal to 0. We're talking about the kinetic energy of a traveling object. If the velocity is less than 0, that means the object is moving backwards, and now you've just broken the laws of physics right now. We're just worried about the positive velocity. So the velocity is going to be greater than or equal to 0. Let's find the domain. I mean the inverse now. We're going to take E equals 4V squared. Notice that I wrote it as just E, not E of V. It's going to help me solve my problem easier. I don't have to worry about function notation. Alright, first thing I'm going to do is get rid of the 4 by dividing it. We're going to cancel the 4's, leaving me with V squared. I'm flipping it over to the left side. It's easier for me. E over 4. We're going to take the square root of both sides. That cancels, so V is equal to the square root of E. Notice what I do with the denominator, since it's just 4 and I know that the square root of 4 is 2. I'm just going to write 2. But since I took the square root, I don't write the radical sign anymore because I just found the square root. If you write the square root, the radical sign here, you're saying, I found the square root of 4, but now I want to find the square root of 2 again. Okay, you don't have to do it twice. So that's my answer right there. Oh, no, I got to write it in function notation, so let's fix that. V of E equals radical E all over 2. There, now that's done. Not this one, right? The bottom one. Okay, it doesn't say to do the check, although you can do the composition to check. But for now, let's leave it like that. We got to answer the second question. The second question says, you guys look here, it says estimate the velocity required for an 8 kilogram object to have a kinetic energy of 60 joules. So what they really want us to focus on is that the new kinetic energy, the kinetic energy of the object we're looking for, is 60 joules. So what I'm going to do is I'm going to take my function here, my inverse, plug in the energy they gave me, which is 60, and then do this estimation. So it's going to look like this. V, whoops, let's undo that. Wrong pen. V of 60, I'm plugging in 60 for E, is equal to radical 60 over 2. We're estimating here, so it's perfectly fine for you guys to use a calculator here, okay? So just punch in radical 60 and then divide by 2, and that'll be your final answer. Okay, so after punching this into my calculator, I get that the velocity for 60 joules is approximately 3.87. Let's look at the units up here to check what we're doing. It says the velocity is in meters per second. 3.87 meters per second. That's the velocity of the object in order to have a kinetic energy of 60 joules. Okay, so at this point what I want you guys to do is go to your side And attempt number, let's look at your side, number 9 and number 10. Once again, like before, take about 4 minutes for each one. Maybe a little longer, actually. These might be shorter, actually. So 4 minutes for each one sounds fair. Take about 4 minutes for each one. Pause the video, then come back once you guys are ready to see the correct answer. Okay, but try it on your own first. So go ahead and pause the video now. Okay, so here's the correct answers for both 9 and 10. Let me quickly explain them. In number 9, what I highlighted here first is the formula they gave me, a of r equals pi r squared, and the instructions, write the inverse function r of a. Very easy to find and very important for you guys to pay attention to what it is that it's asking, right? We're writing the inverse function. So the work for that is all right here. This is the inverse function that I found. I started with a equals pi r squared. Notice that I just wrote it as a without a of r, right, to make it simpler on myself when I solve it. I divided by pi. Then I took the square root of both sides and I ended up with this. Wrote it in function form, so it's r of a equals radical a over pi. The radical covers both the a and the pi, so it's a radical that goes from the top to the bottom, the entire thing. Then what I did after that is figure out the other instructions. The other instructions here that I highlighted in bluish, purple, whatever this color is to estimate the radius of a circular object that has an area of 40 centimeters squared. So that's basically telling me what happens if the area is 40. Plug in 40 for area. So right here for A, I plugged in 40. I did this work on the calculator, basically 40 divided by pi, take the square root, and I got 3.57 centimeters. So if I know the area, 40 centimeters squared, then I know that the radius is approximately 3.57. If you look at number 10 down here, same idea. First thing I did was highlight the formula they gave me right here. Highlight the instructions, write the inverse function. So I took that, here's my work. I wrote it just d instead of d of t. Found the inverse. Using the same steps, divide by 4.9, take the square root. I got this for my inverse, and here it is in function form. Radical d over 4.9, once again with the radical covering the entire thing. Then what I did over here is answer the second question. Estimate the number of seconds it takes an object to fall 150 feet. So they gave me the distance 150, so I plugged in 150 for D, and then once again did that finishing up in the calculator. It's 150 divided by 4.9, then take the square root. My calculator says 5.5. I did not put what that is. That would be seconds though. Let me fix that. Whoops. That would be seconds. 5.5 seconds, because t is in seconds here. Alright, and that is it. Alright, you have your homework, so you're responsible for that. You have the correct page on your notes. I will see you guys on the next one.